Hello guys, I welcome you all to my channel Engineers Academy. Do subscribe my channel if you haven't done it yet. Now we are going to discuss the circle and the standard form of the equation of the circle. So the standard form of the equation of the circle is represented by this. This is x minus h square plus y minus k square equals to a square. So now by definition the circle is the set of all points which are located at some distance, at some constant distance from a fixed point in the xy coordinates. So let's say, or we can say that in the 2D plane. So now let's say that we have some arbitrary point P which is at a distance of a from this particular fixed point, and the coordinates of this fixed point from that origin is h and k. And in case of circle, this fixed point is known as the center of the circle, and this distance is known as radius. So now let's say that we have points which are at some fixed distance from that center, and that distance is known as the radius. So if we have infinite many points at equal distances from that center point, so if we join all these points, so they will make a geometry which is known as circle. So now let's say that the center of this circle is at some point from the origin, and the coordinates of this point from the y-axis or from the origin is h along the x-axis and k along the y-axis. So this is k and this is h. And let's take an arbitrary point which has a coordinates of xy from the center. So this is that arbitrary point, and from the origin it is along the x, it is at a distance of x, and from the origin it is at a distance of y along the y-axis. Now we can find this equation by applying the Pythagoras theorem if we know the distance formula, right? So if I make a vertical line like this, and if I draw a horizontal line, so let's say that from here to here we know that this distance is x, since the center is at this distance is h. This distance is h since the center is at a distance of h from the origin along the x, and this distance is k. And similarly, if this is some arbitrary point pxy, so if the coordinates of this point p are x and y, so we know that this distance is x, and similarly we know that this distance is y. So now to find that equation of the circle, so we can apply the Pythagoras theorem if we consider this right angle triangle. This is the right angle triangle, and we can apply the Pythagoras theorem. So the Pythagoras theorem will be the a square, the hypotenuse square. The hypotenuse of this right angle triangle is this a, which is the radius of this circle, will be equal to the base square plus the perpendicular square. So let me write that this a square will be equal to base square plus the perpendicular square. Now the base square is this change in length, so this length. So now this length will be this x minus h, so that is the base, right? So I can write that the base is x minus h square, and similarly the perpendicular of this right angle triangle is this length, so this length is y minus k, so we will get this length. So the perpendicular is y minus k square, so this will be equal to the radius square. So we can write that this is x minus h square plus y minus k square equals to a square. So now this a is that fixed distance which we call the radius, and this h and k are the coordinates of the location of the center of a given circle. So now if the center of the circle is at the origin, then h and k, if the center point is at the origin, then the h and k coordinates both are 0. and if the radius is equal to 1, if the radius is equal to 1, then we mean that a is equal to 1. So now if we put all these in this standard equation, so we will have x square plus y square equals to 1. So this circle is known as unit circle. A circle which has an origin at which has a center at origin and which has a radius equal to 1 is known as unit circle. So this is the equation of the unit circle. So this is the equation of the circle which has an origin at some point, which has a coordinate of h and k, and which has a radius of a. Now let's solve some exercises from Thomas Finney calculus related to that standard form of the circle. So it says that in exercise 41 to 46, find an equation for the circle with the given center h and k and radius a. Then sketch the circle in the xy plane. Include the circle center in your sketch. Also label the circles x and y intercept, if any, with their coordinate pairs. So now the first exercise is exercise 41. Again, the center is given. The center h and k coordinates are given, that is equal to h is equal to 0 and k is equal to 2, and the radius is equal to 2. So now applying that standard equation, we can write that x minus h, so h is 0, plus y minus k, k is 2 square, equals to a square, that is the radius square. So radius square is 2 square, so this will give us 4. So this is 4. Now we are going to plot this circle. So for that, let me draw the x and y axes. So this is my positive x. So this is our positive x and this is our positive y. So now the center is at 0, 2, so the x coordinate is 0. So the x coordinate is 0 and the y coordinate is plus 2. So we are here somewhere. So somewhere here we have the center, that is C. And it is also said that label the x and y intercept. So the x-intercept, at x-intercept the y coordinate is 0. So now if we put y equals to 0 in this equation, so we will get the x-intercept. So now for at y equals to 0, we will have this equation like x minus 0 whole square, and y minus 0, this will be 0 minus 2 square, this will be equal to 4. So this is x square plus 2 square is 4, and this is 4. So this gives us, if I bring this 4 to the other side of equation, it will become minus, so we will get x square equals to 0, or we can say that x is equal to 0. So the x-intercept is at x equals to 0. So this means that the circle will pass through the origin. So in other words, if we know that this is the center and the radius is 2, so from this center we need to move 2 units in this direction, 2 units in this direction, 2 units in this direction, and 2 units in this direction. So the circle will pass all these points. So this will represent that circle, and that circle is going to pass through the origin. So now let me draw that circle first. So that circle is going to pass all these points. So we will have the circle like this. So we have that point here 0, 0, and this is the center, and the center is at 0, 2, and now this is the y-intercept. So to find the y-intercept, we can put x equals to 0 in this equation. So if we put x equals to 0, we will get the y-intercept. But now this circle is very simple. We can, by inspection, we can say that this point is at a distance of 1, 2, 3, and 4. If the radius is 2, so the dia is 4. So this is, we can say that the coordinates of this y-intercept is 0, the x coordinate is 0, and this is 4. So this is the circle which is represented by this equation. Now the next exercise is exercise 42. Again we are given the center, which is the center is hk, and exercise 42 says that the center is at minus 3 and 0, and the radius is equal to 3. So by using that standard equation, we can say that x minus h, so my h is minus 3 square plus y minus k, so k is 0, and this is equal to a square, which is 3 square. So this will give us x plus 3 square, and this is square, so this will be y square equals to 3 square is 9. So now let's plot this circle. So now the origin is at minus 3 0, so the x coordinate is minus 3, so this is 1 2 3 minus 3 and 0. So the origin the center is somewhere here, so somewhere here is the center, and now the radius is 3, so we need to move 3 units in this direction, 3 units in this, 3 units in this, and 3 units in this. So the circle will pass through all these points, so this will be the required circle. So the center is at minus 3 0, and the x and y intercept at this particular point is 0 0, and this point is another x intercept, and this point will be the y coordinate is 0 at this particular point, and the x coordinate will be minus 6. Since we know that the radius is 3, so this distance along the x-axis will be minus 6. This is minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6. So the coordinates of this particular point is minus 6 and 0. Now the next exercise is exercise 43, and the exercise 43 again gives us the center. So center is hk equals to minus 1 5, and the radius is square root 10. So now again, by using that equation, x minus h, so h is minus 1 square plus y minus k, so k is 5 square, equals to a square, that is the radius square. So this gives us x plus 1 square plus y minus 5 square equals to. Now let's sketch this circle, which has a center at minus 1 and 5 and radius equal to square root 10. So this will be minus 1 1 2 3 4 and 5. So somewhere is the center, which has the coordinates of minus 1 and 5. And then to sketch this circle, we need to find the x and y intercept, since the radius is square root 10. So square root 10 is 3.16. so we cannot accurately plot this 3.16 radius, so for that we have to find the y-intercept and the x-intercept. So for y-intercept, the x value will be equals to 0, since the y-intercept is the point where the circle intersect with the y-axis. So at that particular intersection point, the x coordinate is 0. So now if we put x equals to 0 in this equation, so we will have 0 plus 1 square plus y minus 5 square equals to 10, and this will be equal to, this will become plus 1 and plus y minus 5 square equals to 10, and if we bring this plus 1 to the other side, so it will become minus, so that will be 10 minus 1. So we can write that y minus 5 square, and 10 minus 1 will be 9. And now if we take square root on both sides, so this will cancel out. So y minus 5 will be equal to plus minus 3. So now we can say that y minus 5 is plus 3 and y minus 5 is minus 3. So this minus 5 on the other side will become positive. So 3 plus 5 is 8, and this is minus 3 plus 5, so this gives us plus 2. So the y-intercept is at x equals to 0, y equals to 8, and x equals to 0, y equals to 2. So now 0 and 8. So this is 0 and 1 2 3 4 5 6 7 8. So somewhere is the y-intercept. This is 0 and 8, and the second y-intercept is at 0 2. So 0 and 2, so somewhere here is that point. So this is 0 2. So now as we can see that the circle is going to pass through these 2 points, and it has the center at this particular point. So let me draw that circle. So the circle is going to pass through these 2 points like this, and let's move this circle, but its center is somewhere here, remember. So the circle is going to be like this. So as we can see that the circle which is represented by this equation is not intersecting with the x-axis. So there are no x-intercept, and the y-intercept are at x equals to 0, y equals to 8, and x equals to 0, y equals to 2, and the center point is at -1 and 5. Now the next exercise is exercise 44. The center HK is 1 1, h is 1, k is 1, and the radius is square root 2. Again, using that standard equation, x minus h square, h is 1, plus y minus k, k is 1, that will be equal to square root 2 square. So square will cancel the square root. We will have x minus 1 square plus y minus 1 square equals to 2. Now again, to sketch this circle, we have to find the x and y intercept. So first let me find the y intercept. So at y intercept, x coordinate will be equal to 0. So we can put x equals to 0 in order to find the y intercept. So when x is 0, we will have 0 minus 1 square plus y minus 1 square equals to 2. And 0 minus 1 square will be 1 plus y minus 1 square equals to 2. And if I bring this plus 1 to the other side, it will become minus 1. So y minus 1 square will be equal to 2 minus 1, which will be equal to 1. And if we take square root on both sides, so this will be y minus 1 will be equal to plus minus 1. And from this we can write that y minus 1 is equal to plus 1, and y minus 1 is equal to minus 1. So this minus 1 on the other side will become plus 1. So 1 plus 1, and minus 1 plus 1. So this is plus 2, and this is 0. So now the y-intercept is at 0 2 and at 0 0. So this means that the circle is passing through the origin, and it is intersecting with the y-axis at 0 2. So 0 2. So when x is 0, y is 2, somewhere here, and it is passing through the origin, and the center is at 1 1. So x is 1 and y is 1. So the center is somewhere here. Now let's sketch this circle. So it's going to pass through like this, and let's move this circle since it is passing through the origin. Now as we can see that from the sketch, we can see that the circle is intersecting with the x-axis. This is our x-axis. So we have to find the x-intercept. So now to find the x-intercept, we need to put y equals to 0 in this equation. So now if I put y equals to 0, so we will have the equation x minus 1 square, and then plus 0 minus 1 square, that will be equal to 2. So x minus 1 square, and this will become plus 1 equals to 2, and x minus 1 square, and this plus 1 on the other side will become minus, so that will be 2 minus 1, so this is 1. And again, if we take square root, so we will have, this will cancel out, and x minus 1 will be equal to plus minus 1. And from this we can write that x minus 1 is equal to plus 1, and x minus 1 is equal to minus 1. And this will give us, if minus 1 on the other side will become positive, so x equals to 2, and this will become minus 1 plus 1, so that will be x equals to 0. So the x-intercept is at 2 0 and at 0 0. So now, since we know from here that the circle is passing to the origin, and with the x-intercept is 2 0, so this point is, so the circle need to pass through this point, that is 2 0. So now let's correct this, right? So we need to have the circle which is going to pass through that point. So we need to have the circle like this. So the center is at 1 1, this is at 1 1, this is 0 2, this is origin, and the x-intercept is at 2 0.